consider this. You notice the kid, I'll repeat this, initially rotates with the rotational speed, and then he pulls his arm closer to his body and he gets to rotate faster. Let's repeat it again. Okay. Now, key here. Initially, what do we have? Angular momentum initial is going to be the angular momentum of the platform that we have here, plus the angular momentum of the body of this young man, plus the angular momentum of the arms of this young man, plus the angular momentum of the dumbbells. All of them are going to have the same angular velocity. So my initial angular momentum is going to be moment of inertia of the platform times omega initial, plus moment of inertia of the body of the gentleman times the initial angular velocity, plus moment of inertia of the arms of this gentleman times the angular velocity, plus the moment of inertia of the dumbbells relative to the center of rotation times omega I. Now, in terms of moments of inertia, this does not change. This does not change. However, instead of having the arms stretched, he's pulling the arms closer. So we are going to have a new moment of inertia of the arms. And the new moment of inertia of the arms is going to be smaller than the initial moment of inertia of the arms. Remember, initially the arms were stretched, so it looks like this relative to the center, and then in the second case they are somewhat like this, so they are not as stretched, so we have a smaller moment of inertia because the mass is closer now to the axis of rotation. Now, the same thing with the dumbbells. The dumbbells were here. So they had a large moment of inertia. The final moment of inertia is going to be less because our dumbbells are now closer to the center of rotation. So to have conservation of angular momentum, since we don't have an external torque here, since IA became smaller and ID became smaller, I need to have something to compensate for that. And the something is going to be a bigger angular velocity. So that's why my new angular momentum is going to be IP omega F plus IB omega F plus I prime A omega F plus I prime D omega F. And again, because of conservation of angular momentum, this should be equal to Li. Same angular momentum. However, a larger angular velocity.